A three-phase induction motor is widely used in industrial applications due to its robustness, efficiency, and simplicity. Here's an overview of its working principle and operation. Working principle basic concept. 1. A three-phase induction motor operates on the principle of electromagnetic induction, where an alternating current, AC, in the stator windings creates a rotating magnetic field. 1. This magnetic field induces current in the rotor, causing it to turn. Rotating magnetic field. 1. When a three-phase supply is connected to the stator windings, it produces a rotating magnetic field. 1. The speed of this field is called synchronous speed, which depends on the frequency of the AC supply and the number of poles in the motor. 2. NSN_SNs equals synchronous speed, RPM. 3. FFF equals frequency of the supply, Hz. 4. PPP equals number of poles induction. 1. The rotor, typically a squirrel cage type, is placed within this rotating magnetic field. 1. As the magnetic field rotates, it cuts through the rotor bars, inducing an electromotive force, EMF, according to Faraday's law of electromagnetic induction. Operation slip. 1. The rotor cannot catch up with the rotating magnetic field, it lags behind, creating a relative motion between the field and rotor. 1. This difference in speed is known as slip, and it's essential for torque generation. 2. NRN_RNR equals rotor speed, RPM, torque production. 1. The induced current in the rotor creates its magnetic field, which interacts with the stator's magnetic field, producing torque. 1. The magnitude of torque is dependent on the slip. Higher slip results in higher torque. Load conditions. 1. When the load on the motor increases, the rotor slows down, increasing slip, which in turn increases the induced current and the torque until it reaches a new equilibrium. Components of a three-phase induction motor stator. 1. The stationary part containing windings that create the rotating magnetic field. Rotor. 1. The rotating part that receives the induced current, usually constructed as a squirrel cage or wound type. End bells. 1. Covers on either end of the motor that house the bearings and support the rotor. Shaft. 1. Transfers mechanical energy to the load. Summary: the three-phase induction motor is characterized by its simplicity, low cost, and maintenance-free operation. Its ability to provide high starting torque and robust performance makes it a preferred choice in many applications, such as pumps, compressors, and conveyor systems.